Introducing the Bachmann Spectrum large-scale Heisler locomotive. With this realistically detailed 1 to 20.3 model of the Heisler locomotive, Bachmann has now added the final member of the big three geared locomotive models to its large-scale line. And following in the award-winning footsteps of Bachmann's Spectrum Shay and Climax geared locomotives, the Heisler will be a welcome addition to any large-scale model railroad and the envy of all your model railroading friends. However, before we tell you more about your new Heisler model and how to care for and maintain it, let's take a brief look at the history of the Heisler locomotive. The Heisler geared locomotive came from the fertile mind of Charles L. Heisler. During his lifetime, Heisler received over 60 patents for everything from a vegetable cutter to designs for special devices meant to combine sound with motion picture projectors, thus creating talking motion pictures. However, it is the Heisler locomotive which has made his name so well known today. In 1891, while working for Edward Nichols, president of both the Brooks Locomotive Works and the Dunkirk Engineering Company in New York State, Charles Heisler first conceived of a geared locomotive to compete with the Shay and Climax locomotive designs. Many of his ideas were based on improvements to weak points on the Gilbert and Dunkirk locomotives, being built at that time by Dunkirk Engineering. Like its competitors, the Gilbert, Dunkirk, and Climax geared locomotives, the Heisler had a central drive shaft running the length of the locomotive to transfer power from the cylinders to the drive wheels via bevel gears. The Climax, Dunkirk, and Gilbert locomotives used bevel gears mounted on both axles of the trucks to power all four wheels. The Heisler used bevel gears on only the front axle of the lead truck and the rear axle of the rear truck. Power was transmitted to the second set of wheels on each truck via connecting side rods. Another important difference was that Heisler enclosed his gears in a metal housing, which allowed the gears to sit in an oil bath, as well as protecting them from the elements and objects on the track. The central drive shaft was fitted with flexible couplings that allow it to stay in line with the trucks as they swiveled and negotiated rough track work. Power was supplied to the drive shaft by two steam cylinders mounted in a V configuration in front of the locomotive cab. The first Heisler locomotive was built by the Dunkirk Engineering Company in 1891 for F.A. Addington of North Carolina. In January 1892, Edward Nichols, Charles Heisler's sponsor at the Brooks Locomotive Works and Dunkirk Engineering, died. Neither company showed any interest in manufacturing the Heisler locomotive. They renounced any and all rights to the patents, and Charles Heisler was free to seek another builder for his locomotive. Heisler moved to Philadelphia and made the acquaintance of George Burnham of the Baldwin Locomotive Company. Burnham also owned a large share of the Stearns Manufacturing Company in Erie, Pennsylvania. Stearns made sawmill machinery and was in close contact with lumbermen throughout the region. Subsequently, in 1894, Charles Heisler entered into an agreement with Stearns, which allowed the company to build Heisler locomotives at their Erie, Pennsylvania plant. Charles Heisler worked with Stearns to develop numerous locomotive sizes to meet the demands of the lumber industry. At this time, he made several changes in the Heisler locomotive to correct weaknesses in his original designs. These included two new frame designs, a wagon-top boiler, and an all-weather vestibule cab to replace the open cab design. The cabs are also moved farther back on the boiler to give them more interior room. From 1894 to 1904, Stearns designed and sold approximately 84 Heisler locomotives ranging in size from 14 tons to 60 tons. In 1904, for reasons still not completely known to this day, the Stearns Manufacturing Company decided to close their plant and go out of business. The locomotive and machinery business, including Heisler's patents, were sold to a group of Erie, Pennsylvania businessmen. After resuming locomotive production for 2 years, it was decided to split the locomotive business off from the boiler, engine, and sawmill machinery business. In 1907, the Heisler Locomotive Works was born in a new location in Erie, Pennsylvania. From the very beginnings in 1907, the new Heisler Locomotive Works was successful and was quickly selling locomotives as fast as they could be built. Soon after they began building locomotives, the new company realized that the Heisler locomotive needed some improvements to meet changing conditions and the trend toward larger locomotives. These changes were overseen by George Schwab. Mr. Schwab began his career at the Stearns Manufacturing Company about the time they started building the Heisler locomotive. Schwab was in the engineering department and had assisted Charles Heisler in developing the Heisler locomotive. Schwab was now secretary of the new Heisler Locomotive Company. While he was not the inventor of the Heisler locomotive, he certainly was the driving force behind perfecting it as the years passed. He began by developing new and larger locomotive sizes. Boilers were designed with a lengthened barrow and lowered firebox section. This greatly reduced the excessive angle of the tapered section of the barrel. The I-beam frame design was used on all locomotives up to 42 tons. Heislers that weighed 50 tons or above were built with a diamond frame design. Over the years, Heisler continued to make further design improvements, including a new swivel truck design with increased flexibility for rough track. They also developed a new narrow gauge truck with outside counterweights designed to help reduce bearing wear caused by the action of the truck's side rods. By the mid-1920s, Heisler was building locomotives from 24 to 90 tons. Heislers with superheaters and piston valves would soon be available. The Heisler Locomotive Company used a three-number classification system. The first number was the locomotive's weight in tons. The second figure was the number of driving wheels, and the third was the driving wheel diameter. Thus, a 36-833 was a 36-ton locomotive with 8 driving wheels of 33-inch diameter. In the 1920s, the lumber industry in the United States had already started into a decline. Recognizing this, Heisler began to zero in on other markets with a moderate amount of success. The owners of quarries, strip mines, and some short-line railroads found the Heisler locomotive well suited to their needs. Even so, the 1929 market collapse and the Great Depression that followed almost put Heisler out of business as locomotive sales, already in decline, dried up completely. In 1931, in an effort to generate sales and cash flow, Heisler built a diesel-electric locomotive. It used 2 Buda diesel engines to drive 2 Westinghouse generators, which in turn powered 2 traction motors, which were connected to the drive shaft. The drive shaft drove 2 standard Heisler trucks with 38-inch drivers. Although it proved an operational success from a performance standpoint, commercially it was a bust. The original prototype, although tested by several potential customers, was not sold until 1937. It finally went to the Wickwire Spencer Steel Company. It served Wickwire and its successors until 1970 and was scrapped in 1999. Now, Heisler turned its attention to fireless steam locomotives after the failure of their diesel-electric design. From 1934 until finally closing their doors in 1941, Heisler built at least 29 of these locomotives. Heisler fireless locomotives utilized the latest in steam motive power technology, including piston valves, Walschaerts valve gear, and roller bearings. Although the fireless locomotive product line was somewhat successful, it was not enough. In 1940, the Heisler management team decided to shut down the company and liquidate its assets. As of April 1941, the Heisler Locomotive Works was no more. As a relative latecomer to the geared locomotive field, why was the Heisler so successful? For one thing, the Heisler incorporated several unique features not found on other geared locomotives. The ash pan was a unique design that was simple to dump and easy to clean. The V-type engine only had one crank throw, whereas Dunkirk and Climax used a separate crank for each cylinder. By using half as many gears as the other geared locomotives, the Heisler had fewer working parts to break down or require maintenance. Plus, the Heisler's truck gears were enclosed in a metal housing that kept snow, water, sand, dirt, and debris out, and a gear oil bath in. This feature meant that the Heisler's gears didn't wear out as fast as its competitors, and they were less prone to damage from objects left on the tracks. The Heisler locomotive had a faster operating speed than either the Shea or Climax. It was quicker to reach maximum speed from a standing start. This was an advantage in switching operations. The Heisler's flexibility as a locomotive, not only for logging but also for strip mining, short-line railroads, contractors, and industrial plant operations, also proved quite beneficial. And the Heisler was built to a variety of track gauges, from 24 inches to standard gauge 4 feet 8.5 inches. Although the Heisler was primarily sold in the United States, some did find their way to Mexico, Central America, New Zealand, and the Far East. Another reason for the Heisler's success was the company's efficient and aggressive marketing efforts. Heisler promoted its locomotives with advertisements in the trade journals. Its sales force roamed the country distributing catalogs, brochures, and descriptive literature filled with testimonials from satisfied customers. It sometimes took a real effort to sell the first Heisler to a new customer, but once the initial locomotive was purchased, the Heisler sold itself. Over 100 companies came back to buy from 1 to 12 additional Heislers after buying their first one. This was due in part to the care Heisler took in determining a customer's needs. Each request for a quote generated an extensive questionnaire designed to focus in on the customer's requirements and expectations. In essence, a customer was ordering a standard chassis with lots of custom features. Heisler continually improved its product to meet the needs of its customers. Many different sized locomotives were added or deleted from the line over the years. The driveline flexible couplings were improved. The trucks evolved from a multi-piece bolted-together design to one that used castings and required far fewer parts. Open cabs were replaced with vestibule all-weather cabs, and the type and shape of the boiler was changed. Finally, superheaters and piston valves were added in the 1920s. All of these changes led to a better balanced and more efficient locomotive. Customers saw and appreciated these developments. By 1930, Heisler was outselling Lima's Shea, and Climax had gone out of business.